Okay, so today I'm going over factoring trinomials. Factoring specifically trinomials is one of the skills that you definitely need if you have to go on to take more math classes. So this is a very, very important skill. I'm going to be focusing on factoring trinomials of a specific form. So that would be x squared plus bx plus c. So you could have numbers for b and c. They could be positive or negative, but you have something that's squared and you have no coefficient in front of your x squared term. So this is a very specific form, but we factor these things a lot. And so you want to get really good at it because it'll make your life easier if you're going on to more math classes. So you've seen things in this form when we multiplied out, when we did the FOIL process. When you FOIL binomials, you end up with something in that form. So factoring is undoing the FOIL process. So that's why you're going to get two sets of parentheses with two factors. You're going to have x plus a number on both terms, basically, both factors. You could also have x minus a number. It really depends on what the numbers are, but that is going to be the basic form. So we are undoing the factoring or the FOILing process when we factor. Now, your numbers, whether they're going to be positive or negative, depends on the values, the signs of b and c, or b and c are positive or negative. So there are basically four different combinations of signs that you could have between the b and the c. So if everything is positive, then all of your factors, your numbers, are going to be positive. So you're going to get x plus p and x plus q. P and q are just numbers. So you're just going to have all plus signs. If the middle term, the b, is negative, but the constant c is positive, then both of them are going to be minus signs. Now, if it's negative, then the middle term is either positive or negative. And you're going to have two numbers of opposite signs. One will be positive, one will be negative. And whichever one is negative or which one is positive, that depends on which number is bigger. So if p is the biggest number, then p would have a positive sign if b is positive. If p is the biggest number and b is negative, then p would have a negative sign. So there are four different situations. And you know ahead of time basically what the signs are going to look like. It's just a matter of figuring out what are the numbers. And so this is called the trial and error method or guessing and checking, because you're basically thinking in your head, what numbers do I need, and then what combinations will get me what I need. You may think guessing and checking, well, that seems like it's going to be a very long process, but trinomials in this form are usually so easy to do because there's not a lot of choices that it's pretty simple to do in your head, and you see the same ones over and over again. So you get to the point that you can look at it and you know exactly what the numbers are without even thinking. So that's why we do this process, because it really is almost instantaneous once you see what it looks like, because you're going to see the same patterns over and over again. So let's start with some examples. This form, the first one, y squared plus 18y plus 80. So that is going to be x plus something and x plus something. I'll just say p and q, your two numbers, because all of the signs are positive. So everything's going to be positive there. You have to determine what your numbers are for p and q. The w squared minus 7w plus 12, those are multiplying to a positive. But the negative, so both of these are going to be negative. That's going to be an x minus p, x minus q. So you're going to have two numbers that are both going to be negative. So you know ahead of time. Now, I'm just using x as the form. When we actually factor, you have to use the variable there. But these are just, I'm just using the forms from the previous slide so that you can see the patterns of what it looks like. So the way this works is I'm going to set up that I know I'm going to have y plus something, y plus something. Because y times y gives me y squared. Oh, excuse me, let me get some water. Okay, so y times y gets you y squared because we were reversing the FOIL process. So FOIL, you multiply your first, that gets your y squared. And the last terms of FOIL give you the constant, the 80. So we're looking at, if I just say these are Q, two numbers, P and Q, need to give me 80. So I'm looking for two numbers that multiply to 80. Two negatives add to a negative, and two negatives multiply to a positive. So this one's not as obvious, but if you think about it, there's not a lot of choices of numbers that multiply to 12.
So is it 4 and 3?
That's correct.
Okay. Well.
Yep.
Yep. Okay. I was going to say -4, right? But then I was like, right, we already have our minus signs in there.
Yeah, we already put the minus signs in there, so you don't have to worry about that. They're already there. So yes, 4 and 3, or 3 and 4, whichever order. So you can see that this is just, as long as you know your multiplication and you can add, you can do this really fast. This is why I like factoring, is because it can go really quickly, especially when they're in this form, when you don't have a number in front, because as long as you know your times tables, it's just bam, right there.
Yes, the times tables. I had to go back and print off a chart for myself because it's been a long time. So some of the ones that do a lot in my head I still remember, but some of them are gone.
Yes, yeah, I know my times tables generally up to, I know most of the 12s. I don't go much further than that, but that's usually all I need. So, and that saves you so much time if you can just do that multiplication in your head rather than, using a calculator to try to figure it out.
I can't remember. There was one the other day that threw me. I think it was like 8 times 7. I was like, oh my gosh, it's gone. I had to go find it.
Yeah. 8 times 7 and 9 times 7 are the two that I always get confused, because one of them is 54 and one of them is 56, and they're so close that I always get confused on which one is which. So I totally get it. Okay, so these are ones where we're going to have opposite signs. So I've got w squared plus 4w minus 12, a squared minus 10a minus 24. So when that last term is negative, we have to have a positive and a negative number, because that's how they get to a negative. So I'm going to set up the first one, w and w, and then I know I'm going to have a positive and a negative. And you can see that we're still multiplying to 12, but now we're adding to a different number. So we need to multiply to a negative 12, and we are adding to a positive 4. So the way that I think about this is two numbers that multiply to 12 but subtract in the right way to get to 4.
It's got to be 2 and 6.
That is correct. And so because they're opposite signs, that's why one of them I subtract them, because negative is the same as subtracting. So 6 minus 2 will get me a positive 4. And so I have to put them, I have to make the 2 negative, I have to make the 6 positive. And so the general rule here is if that middle term is positive, the larger the two numbers has to be positive. So that's why the 6 is positive. So if it was a negative 4, it would have been a negative 6 plus 2, and then that would give you negative 4. So the most common error with these is just having the correct numbers with the wrong sign. And you can always double check by doing FOIL, by multiplying it out, and make sure you get what you're supposed to get. Next one here, I have a squared, whoops, let's rewrite it, a squared minus 10a minus 24. So again, I need to have one positive, one negative in order to multiply to 24. So they need to multiply to a negative 24 and add to negative 10. And actually, yeah, making sure that I have everything right. Because I was like, oh, 6 and 4. I'm like, nope, that's not the right signs.
8 and 3? No, not 8 and 3. 12? 12 and 2?
Yes, 12 and 2. So to get to a negative 10, the 12 has to be negative. So that's a negative 12 and a positive 2. And so it's tricky because 6 and 4 also gets you to 10, but we have to pay attention to the signs because in order to get negative 10, they both have to be negative, but then you would have to multiply to a positive 24. So there could be different combinations that can add to the same middle number, but you have to make sure you have the signs right so that you can get the correct combination. So if I'll just write that one. If we had instead x minus 4, x minus 6, that would have been a squared minus 10a. So that part would have matched, but then we would have had plus 24. So when you're factoring, you really have to pay attention to those signs because one sign difference can completely change which numbers you use. Now, when things say to factor completely, that means we have to factor. My voice is getting all stuck again. Okay, so when we have to factor completely, that means we have to factor out the greatest common factor first, and then we factor. So, and the default is always factor completely, even if it doesn't tell you to. So first, when we factor, we always factor as much as possible so that we always take the greatest common factor first, or out first. So the first one here, we have a negative y squared minus 12y minus 35. So if you watched my GCF video, and I know I only just, let's see, it was on YouTube yesterday, but I only just emailed it out today, I think. We're looking for numbers that can divide into 1 with the y squared, 12, and 35, and we need the same number. Well, they don't have any numbers in common. So we can't factor a number out of there. We can't divide out a number. But if the first term, that y squared, is negative, we always remove a negative. So I'm going to remove a negative 1. And what that means, actually, I want to make this black.
Changes the signs.
Yes. So everything changes signs. So now that's a positive y squared, a positive 12y, and a positive 35. And we do that because whenever we factor, we need to factor with a positive squared term. If we have that negative, it gets much harder to factor because now you have to consider an extra negative when you're doing your multiplication. So we just always factor out a negative if that first term is negative. So now how this works is I'm factoring my y squared stuff. So that negative one just kind of hangs out in front, and then we have our y and our y. I'm multiplying to a positive, adding to a positive, so those both have to be positive. So now we need two numbers that multiply to 35 and add to 12.
7 and 5.
That's correct. And there you go. That is completely factored. This is probably, if you can do your multiplication tables, this is probably the easiest thing you've done all term.
Uh-oh, I see a larger number coming.
Yes. That is why we want to factor out the greatest common factor, because the combinations of things that multiply to 198, there's a lot of them. But if we factor out numbers in common, that gives us fewer choices, and it makes our life a lot easier. So the greatest common factor here, when I'm looking at, let me actually make sure those look like letters. So the greatest common factor, the GCF, we're looking at a number I can divide out of 2, 4, and 198.
So 2.
Yep. So they're all even, so I can divide out a 2, and that's the largest thing I can divide out. So I'm going to put my 2 in front, and then I'm going to divide each of those numbers by 2. So that leaves me z squared, 2z, and then 99. So now, instead of trying to multiply to 198, we're only multiplying to 99, which is actually a lot easier to do. So we need two numbers that multiply to a negative 99, which means we're going to have a positive and a negative. So that means when they subtract, you're going to get 2.
So you got 11 and 9.
Mm-hmm. Which one's positive, which one's negative?
Okay, so it's the 11 positive?
Yes.
Okay.
Yeah, so 11 minus 9 is 2. And you can get that because the middle term is positive, so 11's bigger than 9, so that's going to go with the positive. So it's a lot easier. 9 times 11 is a lot more obvious in your head than try to figure out what would multiply to 198. Now I'm ramping up the difficulty here, as usual. So the first one I have here is negative 40d minus 30 minus 10d squared. In order to factor, we have to have everything from the highest exponent down to the lowest. It has to be in a specific order. This is not in the order that we want. We need our exponents going from high to low. So we have to first rewrite this. So that's going to be negative 10d squared minus 40d minus 30. So you have to get that d squared first before we do anything else. Now we want to find the greatest common factor. And because my first term is negative, I'm going to be dividing out a negative. And now I want
negative 10?
Yes. Yeah, so we're going to divide out a negative 10. So I'm going to have my negative 10 in front and then divide each of these by negative 10. So negative 10 by negative 10 is 1. So that's going to just give me a d squared. And then the negative 40 divided by negative 10, that's going to be a positive 4d. And then negative 30 divided by negative 10 is a positive 3. So you can see already, taking out that greatest common factor really made your numbers much smaller. And it really limits your possibilities because we need numbers that multiply to 3. There's only one set of numbers that multiply to 3, 1 and 3. And then we need to add them to 4, so 3 plus 1 is 4. So we don't even have to really do guessing and checking. And so that's one of the things, like when you do a lot of factoring, like this d squared minus 4d plus 3, that combination of numbers shows up so many times that I look at it and I don't even think about it anymore. I just know what it looks like. Now the second one that I have here, 5w to the fourth minus 35w cubed plus 50w squared. So to find the greatest common factor, we need to first look at the numbers, the biggest number I can divide out of 5, 35, and 50.
So it'd be 5w squared.
Yes, yes. And we take that w squared since that's the smallest exponent. And so I usually divide this out in my head, but I am going to show the steps that I do because once it starts involving variables, people are more prone to making mistakes. So I take each of my terms and I'm dividing that 5w squared out of them. So that leaves me 5w squared. And then the 5's cancel. You subtract the exponents, you get w squared. Then minus 7w plus 10. Now I'm going to factor the w squared minus 7w plus 10. So I know I need to have a w and a w. I'm multiplying to a positive and adding to a negative. So this means both of them are going to be negative. So now I need two numbers that multiply to 10 but add to 7.
5 and 2.
Yep. And then that's it. We're done. So that are all the examples that I had. It's once you understand the pattern and what you need to do, and it's really not that bad. I should actually leave it in case you're still writing. The hardest part is just probably figuring out the greatest common factor and getting that out first. Because if you don't, it's a lot harder to figure out how to factor it because you've got these extra things you don't need. Now, go ahead.
I was going to say, I think I had a question earlier when I was working through problems, but I think whenever I watched the video from last night, I think it answered my questions. I was just skimming back through my notes to make sure I didn't have anything else pop up.
Yeah. And on Monday, I'm going to go through the second part of factoring where that number, if you try to get rid of that number in front of the squared term, doesn't disappear. Because sometimes you can't take out a greatest common factor and you're still stuck with a number in front. The book goes through trial and error for that. And then there's something called the AC method. And so I like the AC method for that. So on Monday, I'm going to go through the AC method, which I also call factoring by grouping because you are creating something you can factor by grouping. And factor by grouping is, I think it's covered in the first section you guys had to read. I get confused on what number is what number. And like I think it goes over like the greatest common factor and factoring by grouping. But I go through that when I do the AC method because you're using grouping. So that's like the second method for factoring when you have things that don't come out as nicely as these. And so that will be Monday at 11 a.m.
Okay. Thank you so much.
You're welcome. I'm glad that you were able to join. And actually, I love that you were answering my questions and making this more interactive because that's much more fun than if I had just been talking to myself.
I was glad I was able to answer the questions on the spot since there was no one else to answer.
Yeah, well, I wouldn't have asked you if I didn't think you could do it. So.
Well, thank you. I really appreciate the live sessions.
I'm glad that they're helpful. Yeah, so I'm probably gonna go get some lunch. So I hope you have a great Friday and a wonderful weekend, and hopefully the weather is nice for you.
It is right now, and I am on to another conference call.
Oh, fun times, fun times. All right. Well, hopefully you can join me on Monday. If not, of course, the video will be posted. So.
Thank you. Enjoy your lunch.
You're welcome. Thanks. Okay. I'll talk to you later.
Bye.
Bye.